Hi everyone, today you are going to view virtual reality as well as the augmented reality. This is from Arizona Info Solutions Private Limited. As of entire course, you can able to know about entire history of virtual reality as well as the augmented reality in this latest trends. Thank you.
5. Google Cardboard. Buy a cardboard viewer or compatible viewer, $10 plus. 6. Unity3d. Who has Unity3d experience? 7. Lecture schedule, 13 lectures, July 26th, 1. Introduction, No Lab, August 2nd, 2. VR Technology, Intro to Unity, August 9th, 3. VR Content Creation, Intro to Cardboard SDK, August 16th, 4. VR Systems, Building VR Scenes in Unity, August 23rd, 5. 3D User Interfaces, Scripting in Unity, August 30th, 6. Interaction Design, Navigation in VR, Sept 6th, 7. VR Applications, Interaction in VR, Sept 13th, 8. Introduction to R, Interaction in VR, October 4th, 9. R Tracking, Building Apps Using AR Toolkit, October 11th, 10. R Interface Design, R Tracking, October 18th, 11. Mobile R, Handheld R Interaction, October 25th, 12. R Applications, Handheld R Interaction, November 1st, 13. Research Directions, No Lab. 8. Projects, Assignment 1, VR Scene, August 23rd. Create a VR scene with at least 10 objects in it, include complex 3D models, texture, skybox, lighting, animations, deploy to Google Cardboard. Assignment 2, VR Interaction, September 13th. Add interactivity to the VR scene, movement navigation, ability to select and manipulation objects. Assignment 3, R Application, November 1st. Handheld R Application, using image-based tracking, screen-based interaction techniques. 9. What you will learn, what augmented reality, virtual reality is, history of R/VR, current R/VR commercial market, different R/VR applications, human perception side of VR/R, R/VR technology, 3D user interface guidelines, how to design good R/VR experiences, how to build your own R/VR applications, important directions for future research in R/VR. 10. What is virtual reality? 11. Ivan Sutherland, 1963, Sketchpad, first interactive graphics program. 12. Ivan Sutherland Sketchpad demo, www.youtube.com web link. 13. The ultimate display. The ultimate display would, of course, be a room within which the computer can control the existence of matter. A chair displayed in such a room would be good enough to sit in. Handcuffs displayed in such a room would be confining, and a bullet displayed in such a room would be fatal. Ivan Sutherland, 1965. 14. An invisible interface. 15. Holodeck, 1974, first shown in Star Trek, the animated series. 16. Holodeck video, www.youtube.com web link. 17. Trend towards invisible interfaces, trend from room scale to invisible computing, making computers invisible, hide the computer in the real world, ubiquitous computing, put the user inside the computer, virtual reality. 18. Making interfaces invisible. Reikimoto, J. and Nagao, K. 1995. The World Through the Computer, Computer Augmented Interaction with Real-World Environments. In Proceedings of the 8th Annual ACM Symposium on User Interface and Software Technology. US 95. ACM, New York, 2936. 19. Graphical user interfaces, separation between real and digital worlds, WIMP, windows, icons, menus, pointer, metaphor. 20. Ubiquitous computing, computing and sensing embedded in real world, particle devices, RFID, motes, Arduino, etc. 21. Virtual reality, 1985. 22. Virtual reality, immersive VR, head-mounted display, gloves, separation from the real world. 23. What is virtual reality? 24. VR goggles and gloves, www.youtube.com web link. 25. Types of VR 25. 26. Other definitions. Virtual reality is a computer technology that replicates an environment, real or imagined, and simulates a user's physical presence and environment to allow for user interaction. Wikipedia, electronic simulations of environments experienced via head-mounted eye goggles and wired clothing enabling the end user to interact in realistic three-dimensional situations. Codes, 1992, an alternate world filled with computer-generated images that respond to human movements. Greenboom, 1992, an interactive, immersive experience generated by a computer. Pimento, 1995. 27. Key characteristics for VR. Virtual reality has 3 key characteristics: 3D stereoscopic display, wide field of view display, low latency head tracking. When these 3 things are combined, they provide a compelling immersive experience. 28. Defining characteristics, www.youtube.com web link. 29. VR experience, this is so real. www.youtube.com web link. 30. Defined in terms of presence, presence is the key to defining VR in terms of experience. Presence is defined as the sense of being in an environment. Telepresence is defined as the experience of presence in an environment by means of a communication medium. A virtual reality is defined as a real or simulated environment in which a perceiver experiences telepresence. 31. David Seltzer's Ape Cube. Autonomy, user can to react to events and stimuli. Interaction, user can interact with objects and environment. Presence, user feels immersed through sensory input and output channels. Interaction. Autonomy. Presence. VR. Seltzer, D. 1992. Autonomy, interaction, and presence. Presence, teleoperators and virtual environments. 127-132. 32. Defined in terms of user experience inducing targeted behavior in an organism by using artificial sensory stimulation, while the organism has little or no awareness of the interference. Lavelle 2016, Targeted Behavior, having an experience designed by another person. Organism, person or other life form, artificial sensory stimulation, one or more sensors replaced by artificial means, awareness, organism unaware of the interface. 33. Virtuoxomni, human on VR treadmill, www.youtube.com web link. 34. Fly on treadmill, insect VR, fruit fly on treadmill and VR display, www.youtube.com web link. 35. Augmented reality 1977, Star Wars. 36. Augmented reality definition, defining characteristics, Azuma 97, combines real and virtual images, both can be seen at the same time. Interactive in real time, the virtual content can be interacted with, registered in 3D, virtual objects appear fixed in space. Azuma, R. T. 1997. A survey of augmented reality. Presence, 6-4, 355-385. 37. 2008, CNN www.youtube.com web link. 38. Put our pictures here augmented reality examples. 39. Pokemon Go. 40. RVSVR. 41. Making interfaces invisible Reikimoto, J. and Nagao, K. 1995. The World Through the Computer, Computer Augmented Interaction with Real-World Environments. In proceedings of the 8th Annual ACM Symposium on User Interface and Software Technology. US 95. ACM, New York, New York, 2936. 42. From Reality to Virtual Reality Ubiquitous Computing Augmented Reality Virtual Reality. 43. Milgram's Reality Virtuality Continuum Mixed Reality Virtuality, RV, Continuum Real Environment Augmented Reality, R, Augmented Virtuality, Avenue, Virtual Environment anywhere between the extrema of the virtuality continuum. P. Milgram and A. F. Kishino. Taxonomy of Mixed Reality Visual Displays II's Transactions on Information and Systems, E77D12, pages 1321 to 1329, 1994. 44. Augmented Virtuality, VR with Windows into the Real World. 45. Other Context, the Metaverse, Neil Stephenson's Snow Crash. The metaverse is the convergence of 1. Virtually enhanced physical reality, 2. Physically persistent virtual space, Metaverse Roadmap, metaverseroadmap.org. 46. Metaverse Dimensions, augmentation technologies that layer information onto our perception of the physical environment. Simulation refers to technologies that model reality. Intimate technologies are focused inwardly, on the identity and actions of the individual or object. External technologies are focused outwardly, towards the world at large. 47. Metaverse Components, 4 key components: virtual worlds, augmented reality, mirror worlds, lifelogging. 48. Mirror worlds. Mirror worlds are informationally enhanced virtual models of the physical world. Google Earth Mississippi Street View, Google Maps. 49. Mark's House in New Zealand. 50. Lifelogging, technologies record and report the intimate states and life histories of objects and users, Nokia Life Blog, Nike Plus, Fitbit. 51. Narrative clip, wearable camera, automatic picture capture, 2 pics, minute, getnarrative.com. 52. Summary, virtual reality can be defined in a number of ways, in terms of technology, from a presence perspective, in terms of user experience. VR can also be classified with other technologies, invisible interfaces, Milgram's mixed reality continuum, metaverse. 53. History of VR. 54. VR History Timeline Immersive Lifelog.files.wordpress.com web link. 55. When anything new comes along, everyone, like a child discovering the world, thinks that they've invented it, but you scratch a little and you find a caveman scratching on a wall is creating virtual reality in a sense. Morton Heelig, Hammett 1993. 56. Early history, 30,000 BC-. The history of VRs are rooted in humans' first attempts to reproduce the world around them. 57. 1800s, capturing reality, panoramas, 1790s, immersive paintings, photography, 1820-30s, oldest surviving photo, Niepce, 1826, stereo imagery, 1830s, Wheatstone, 1832, Brewster, 1851, movies, 1870s, Muybridge, 1878, Roundy Garden Scene, 1888. 58. Stereo viewers Wheatstone, 1832, Brewster, 1860. 59. Viewmaster, 1939. 60. 3D Cinema Golden Era, 1956 DS, polarized 3D projection or anaglyph, red, blue. 61. 1900s, interactive experiences, early simulators, 1960s, flight simulation, Sensorama, 1955, early HMDs, 1960s, Philco, Ivan Sutherland, Military plus University Research, 1978 DS, U.S. Air Force, NASA, MIT, UNC, First Commercial Wave, 1989 DS, VPL, Virtual I/O, Division, Virtuality, VR Arcades, Virtual Boy. 62. Pygmalion's Spectacles, 1935, Stanley Weinbaum short story, main character, Dan Burke, tries a pair of goggles the goggle provide, a movie that gives one sight and sound, taste, smell, and touch. You are in the story, you speak to the shadows, characters, and they reply, and instead of being on a screen, the story is all about you, and you are in it. 63. Link Trainer, 1929 to 1950s, flight simulator training, full 6-degree of freedom rotation, force feedback and motion control, simulated instruments, modeling common flight conditions, over 500,000 pilots trained. 64. Link Trainer Video, 1966, www.youtube.com web link. 65. Sensorama, 1955, created by Morten Heilig, Experience Theater, Multisensory, Visuals, Sound, Wind, Vibration, Smell, no financial support, commercial failure. 66. Sensorama Video, www.youtube.com web link. 67. Early HMD patents. 68. First HMD, 1961, Philco head-side remote camera viewing, components, HMD, closed-circuit television, custom magnetic tracking for head orientation. 69. Ivan Sutherland, 1960s, 70 Ivan Sutherland's head-mounted display, 1968. 70. Sutherland Display www.youtube.com web link. 71. Super Cockpit, 1965 ADS, U.S. Air Force Research Program, Wright-Patterson Air Force Base, Tom Furnace 3, multisensory, visual, auditory, tactile, head, eye, speech, and hand input, addressing pilot information overload, flight controls and tasks too complicated, research only, big system, not safe for rejecting. 72. UNC Haptic Systems, 1967 to 80s, haptic, kinesthetic display system, 6D force fields of molecular structures, progression, group I, simple fields, particle feedback, group 2, 1978, children's building blocks, group 3, late 80s, remote manipulator, Zarco's arm. 73. Star Wars, 1977, use of 3D graphics and R interfaces. 74. Aspen Movie Map, 1978, Andrew Lippman, MIT, car driven through Aspen, 4 stop-motion cameras, pictures every 10 feet, interactive playback, played from Laserdisc, touch screen, people able to navigation in any direction, map interface, 3D graphics overlay, early version of Google Street View. 75. Aspen Movie Map Demo, www.youtube.com web link. 76. Video Place, 1975 ADS, Myron Kruger, graphics, gesture recognition, real-time interaction, video desk, camera captures gestures, relays to remote collaborator, gestures control graphics, paint, draw, menu selection, Wrote artificial reality 2. 77. Video Place Demo, www.youtube.com web link. 78. Leap Optics, 1979, Large Expanse, Extra Perspective Optics, developed by Eric Howlett, lens designed for extremely wide field of view, high resolution in center, lower resolution in periphery, 90 direct FOV, 140 corneal FOV, used as basis for most VR HMDs. 79. Leap Optics Design. 80. Thrawn, 1982, ASTFA. 81. The Data Glove, 1981-82, Precursor, Serre Glove, University of Illinois, 1977, Thomas Zimmerman, 1982, Fiber Optic Bend Sensors, Detecting Finger Bending, commercialized by VPL, Metal Power Glove, 1989. 82. VPL Data Glove Demo, www.youtube.com web link. 83. NASA View/5, 1981-86, Early HMD, McGreevy Humphreys, LCD Watchman Displays, View, Scott Fisher, Polhemus Tracker, Leap-based HMD, 3D Audio, Convolvitron, Data Glove Gesture Input, Simple Graphics. 84. Virtual Interface Environment Workstation, Motorbike Helmet plus Leap. 85. Jaron Lanier, founded VPL, coined term virtual reality. 86. VPL Research, 1985 to 1999, first commercial VR company, Jaron Lanier, Jean-Jacques Grimaud, provided complete systems, displays, software, gloves, etc., Data Glove, iPhone, Audiosphere. 87. The University of North Carolina at Chapel Hill, 1980s-1990s, 8-9 head-mounted displays tracking, haptics, applications. 88. University of Washington, 1989, Human Interface Technology Laboratory, HIT Lab, founded by Tom Furness. 3. Mini R/VR Innovations, Virtual Retinal Display, AR Toolkit, R Tracking Library, Green Space Shared VR Experience, VR and Pain Care, VR and Education. 89. The Virtual Retinal Display, 1991, image scanned onto retina, commercialized through Microvision, Nomad System, www.mvis.com, lead to Magic Leap Technology. 90. Lawnmower Man, 1992. 91. VR Learning in Lawnmower Man, www.youtube.com web link. 92. Cave, 1992, Projection VR System, 3/6 wall stereo projection, viewpoint tracking, developed at EVL, University of Illinois Chicago, commercialized by Meshstein Corporation. 1996. C. Cruz-Nara, D. J. Santon, T. A. DeFanti, R. V. Kenyon and J. C. Hart. The Cave, Audio-Visual Experience Automatic Virtual Environment, Communications of the ACM, Volume 35-6, 1992, pages 64 to 72. 93. Cave Demo Video, www.youtube.com web link. 94. Desktop VR, 1995, expensive, $150,000 plus, 2 million polys per second, VGA HMD -30 Hz, magnetic tracking. 95. Virtual reality was hot, in 1995. 96. My VR Predictions, 1996, I knew everyone would use Everwin, HMDs were cheap, $500, computers generate millions of polys per second, tracking was inexpensive, good 3D input devices. 97. Rise of commercial VR companies, W Industries, Virtuality, 1985 to 97, location-based entertainment, Virtuality VR Arcades, Division, 1989 to 1998, turnkey VR systems, visual programming tools, Virtual I/O, 1993-1997, inexpensive gamer HMDs, Sense8, 1990-1998, World Toolkit, World Up, VR authoring tools. 98. Dactyl Nightmare, www.youtube.com web link. 99. Overview of VR in the 1990s, www.youtube.com web link. 100. April 2007 Computer World, VR voted 7th on list of 21 biggest technology flops, MS Bob number 1. 101. Lessons learned, don't believe the hype, not everything is better in VR, many factors determine technology acceptance, human-centered design, design for users, need to move from demo to production, profitable niche markets first, follow the money. 102. VR Second Wave, 2010, Palmer Luckey, HMD Hacker, Mixed Reality Lab, MXR, Intern, Oculus Rift, 2011, 2012, $2.4 million Kickstarter, 2014, $2 billion acquisition Facebook, $350, 11005. 103. The Oculus Kickstarter video, www.youtube.com web link. 104. Desktop VR in 2016, graphics desktop, $1,500, greater than 4 billion poly per second, $600 HMD, 1080 by 1200, 90 Hz, optical tracking, room scale. 105. Oculus Rift Sony Morpheus HTC, Valve Vive 2016, Rise of Consumer HMDs. 106. HTC Vive, room scale tracking, gesture input devices. 107. Example Vive app, Tilt Brush, www.youtube.com web link. 108. VR2 Go, 2013, MXR Lab, 3D print VR viewer for mobiles, open source hardware plus software, projects.ict.usc.edu web link, early mobile VR viewer. 109. Google Cardboard, release 2014, Google 20% project, greater than 5 million shipped, given away, easy to use developer tools plus equals. 110. Many different cardboard viewers. 111. Multiple mobile VR viewers available. 112. ZXCVZ. 113. Gartner Hype Cycle, 2016. 114. Gartner Hype Cycle, 2016. 115. Projected HMD sales, ASTF. 116. Market size. 117. R/VR market size, SAF. 118. R/VR investments, greater than $1 billion USD from VCs, greater than 120 deals in US alone. 119. Companies, STFA. 120. STAs. 121. Potential for disruption, BDMI, AST. 122. Why 2016 won't be like 1996, it's not just VR anymore, huge amount of investment, inexpensive hardware platforms, easy to use content creation tools, new devices for input and output, proven use cases, no more hype. Most important, focus on user experience. 123. Conclusion, virtual reality has a long history, greater than 50 years of HMDs, simulators. Key elements for VR were in place by early 1990s, displays, tracking, input, graphics, strong support from military, government, universities. First commercial wave failed in late 1990s, too expensive, bad user experience, poor technology, etc., we are now in second commercial wave, better experience, affordable hardware, large commercial investment, significant installed user base. Will virtual reality be a commercial success this time?